Welcome to our calculus class. Our topic for today is find the values of derivatives using limits. Derivatives using limits. Find the derivative of gx equals x of x equals -12. Before to find the answer to our problem, remember the derivative is the concept for the class. The derivative of fx of f of x at x equals 8 is f of a equals limit of f of a plus h minus f of a divided by h when h approaches to 0, right? This is the main concept. Another idea is the derivative of f of a f of a is both. What I mean this, one idea, the instantaneous rate of change is this main concept, instantaneous rate of change of f of x, okay, at x equals 8. And there is another idea, and the other idea, the slope is another main point of the tangent. Tangent is another concept, line. Yeah, the tangent line to the curve y equals f of x at x equals 8 when f of x is a linear function. Correct? It's a linear function. The derivative always is equal to the slope. Here as a conclusion, the derivative is always equal to the slope. All right, this is the main concept for our class. This concept describes the whole class. This is the main idea. After this, let me show you how the practice class. So this is the theory class. All right, I will erase 2 main points here that is important to remember when you're working in this kind of problem. Derivative using limits. Okay, what I mean this, maybe you didn't understand this concept, some abstract concept. So now we have to solve a problem. Solve. How solve? I will remember some concepts since, look at this, since gx, that's very important to write it, is a linear function. So here is a linear This is very important to write it with a slope. Where is the slope here? With the slope 1. Okay, very important. The slope 1. We need it to solve, find the answer. The derivative, and after the constant, remember, the derivative is the same. Is 1, 2. It's 1, right? You can also find the derivative. Also, it's another way. Of g of x, this is another way, equals x at x equals -12. -12, right? Using the limit definition. Using the limit definition. All right. What is the limit definition? The limit definition, it is, let me write here, g, it's g parenthesis 12. So g of -12 equals limit of what? Right. The main formula, g times or -12. Here just using the formula plus h minus g of -12 divided by h when h approaches to 0. This is the limit definition. All right. So you cannot simplify here. You cannot simplify by plugging in h. It is not allowed h. For instance, h equals 0. No, to evaluate the limit, because doing the or making the denominator 0, you can do it. You must finish simplify. I mean, you not simplify the numerator. You must to simplify the numerator on top, and cancel the h denominator. All right. So we have to simplify the numerator, the top one, and then cancel the denominator in the bottom. So let's see how do this. So I will follow this step. Okay, look our problem. So just write g like prime parenthesis -12. So like that. So simplify. This will be equals here equals limit of what? Limit of g of -12 plus h minus g time, or right there, I need to close the parenthesis here. Close the parenthesis, so it's -12 here. 2 divided by h when h approaches to 0. See? So next step, just try to simplify here. Next step will be equals here, limit again. Now simplify here, we are going to have a -12 plus h minus cancel g right here, -12 right there, divided by h. So when h approaches to 0, here this step, next step is equals here will be equals, you cancel there, limit when h approaches to 0. Here you will have cancel 12 because this is negative and this will be positive, right? Negative is positive, so h divided by h, right? So when you have h negative, h positive divided by h, so here it will be equals, next step is equals limit when limit of what? Limit of h divided by h is 1, right? Limit of 1 when h approaches to 0. Here is cancel h. Here cancel h. Right here. This is the answer. Here, the answer is 1. This is the derivative. The answer, right? So let me show you another problem. I will erase this and then now no explain anything. Just write the problem. So the next one, find the derivative of gx when gx is equals 5. Right here 5 and then x of x. Here x is equals negative 10. See the difference right now? So you can also find the denominator. Here, let's write, you can also find find the denominator of what? Of k. Let me write different letters right here. kx, yeah, like that. So to do something different, right? So now k of x equals 5 at x equals negative 10. Look the data right there. Using the limit definition here. Using the limit definition. Using the limit definition to try to find the answer. Alright, so let's go. So first step, k prime of what? Of negative 10. Right? So next step is just follow step. Remember the last problem? We will have k negative 10 equals, here will be equals limit of k of negative 10 plus h minus k of negative 10 divided by h, when h approaches to 0. Okay. Yeah, this is the limit definition. This is the limit definition, right? But the k negative. This is actually our first step. K. I write it again. Negative 10. The next step will be equals. Will be equals. Let me use the black color. Limit. So use the limit k negative 10 plus h minus k negative 10 divided by h when h approaches to 0. Right? Now it's here we equals limit. Simplify this. You simplify that, we will have cancel k, because it's a positive negative, you cancel here. What's k? Let me touch the letter. Cancel this, and then also 10, because it's a positive, cancel that. You will have h. Oh, but this is 5. Remember 5? We will have 5. Minus, k, not cancel. It's k. So we'll have k 5, negative 5, minus 5 divided by h, when h approaches to 0. Alright, so now the limit, this is equals limit of what? 0 is 0. Here the limit is 0 of when h approaches to 0. Right? That's it. So the answer here is equals 0. So the derivative of this problem is 0. Right? That's the answer to our problem. So that was our class about the derivative using limits in calculus. That's it. As always, I remember, if you discover the power of the mathematics, unleash your infinity potential. Thank you so much.